Okay, so what we want to talk about today is vertex form. So I've got an f of x equals a times x minus h squared plus k. And what you'll notice is that I've got three terms here. So this is vertex form. And our goal for today is to try and get some of these quadratics into vertex form and graph them depending on where they're shifting. So x minus h quantity squared, this h will tell you where you're shifting left and right. The k will tell you where you're shifting up and down, okay? So, right, h tells me to shift right to left, or sorry, left to right. Yeah, it's inverted for you. So left to right or up and down, okay? And then f of x equals x squared plus 2x minus 3 is our first example. So if you've been following along with some of the lessons, negative 3 is actually where you're going to hit the y-axis. So if I look over here and I look on this graph, you'll see that I already have that point marked. So negative 3 in blue, right? That's where that function is going to hit the y-axis. So that c term of your quadratic, whenever it's in standard form, ax squared plus bx plus c, it's going to tell you where you're going to hit the y-axis. Now, past that, we want to put this in vertex form. So the first thing we're going to calculate is h. And so h is going to be this every time. It's going to be h is negative b over 2a. And so if I take a look at a, b, and c for my quadratic, my a is 1, my b is 2, and then my c is negative 3. So the only ones I need to look at are b and a. So b is 2, so I've got negative 2 over 2 times a, which is 1 in this case. So negative 2 divided by 2 is negative 1. So I'm left with negative 1. So I've got h, which is negative 1. And to find k, you're going to plug it back into the original function. So in other words, you're going to calculate f of h, which is the same thing as f of negative 1 in this case. So you're going to plug negative 1 into the function. So if I plug negative 1 in, I'm going to get negative 1 squared plus 2 times negative 1 minus 3. So negative 1 squared is positive 1. 2 times negative 1 is negative 2 minus 3. So I've got 1 minus 2 is negative 1 minus 3. And then I've got negative 4. Okay? So this tells me where it's shifting. So what I'm going to do is construct that function. The a term on f of x, this vertex form, is going to be the same as your a term with your particular function. So in this case, my a term is 1. So if you take a look here, I'm going to start to construct f of x. F of x is equal to 1 parentheses x minus h. Now h is negative 1. So I'm going to plug in negative 1 for h squared. And then my k value is going to be what I got for f of h. So f of h here, you'll see, f of h you'll see here is negative 4. So if I plug that guy in, I get negative 4 down here. So if I clean this up, I've got minus of a minus, which is a plus. So x plus 1 squared. And then minus 4. So this tells me where to shift the function. So this function is shifting left 1 and down 4. So left 1, down 4. So I'm going to put a blue dot there. So negative 1, negative 2, negative 3, negative 4. Okay, so I've got 1 times x plus 1 squared minus 4 equals f of x. So if that's the case, I want to find where it hits the y-axis. I mean, not the y-axis, we already found that. I want to see where it hits the x-axis. So if I want to see where it hits the x-axis, what I'm going to do is set this function equal to 0. Because if you notice, to find where it hits the x-axis, that's the same as finding where the y value is 0. So if you notice, if I'm on the x-axis, any point on the x-axis, its y value is 0. So we're going to take f of x, or y, and set it equal to 0. So I get 1 times x plus 1 quantity squared minus 4 equals 0. So I'm going to set f of x equal to 0. And I'm going to solve for x. So I've got, I can add 4 to both sides. You get x plus 1 squared equals positive 4. And I'm going to take the square root. And I get x plus 1 equals plus or minus 2. And then I'm going to subtract 1 from both sides of the equation. And I get x equals negative 1 plus or minus 2. So I've got two solutions here. I've got x equals negative 1 minus 2, and then negative 1 plus 2, which is negative 3 and 1. So it's going to hit this x-axis at negative 3. And positive 1. There it is. And so this quadratic is opening up, and that is the entire function. And so I can graph just by looking at this function and putting it in vertex form, so it might seem a little daunting here, but we're going to do a few more examples. So let's take a look at our next example. So this time I'm going to call it h of x. I'm going to call the function h of x. It's going to be x squared minus 2x minus 8. And so I can already start to see some features of this function. This features of this function, so I'm going to go over here and graph that. Some of the features. And so if you take a look here, I've got to graph it. I've got x squared minus 2x minus 8. So a is 1, b is negative 2, and c is negative 8. And so that c term tells me where it's going to hit the y-axis. So if I look over here, negative 1, negative 2, negative 3, all the way down to negative 8. So that's where it's hitting the y-axis. Okay, so I know where it's hitting the y-axis, so now all I want to do is find the opposite of b over 2a. So my h value, not this h value, I'm talking about the h value up here. So I don't mean to confuse you there. This h term is opposite of b over 2a. So we're going to calculate opposite of b over 2a for this function. So negative b over 2a is equal to negative of negative 2 divided by 2 times 1. So negative of a negative is a positive, so I get 2 over 2, which is positive 1. So if I want to find the k value, it's going to be equal to h of 1 in this case. So I'm going to plug in this guy in for x here. So I get 1 squared, so it's dropping in here and there. So I get 1 squared minus 2 times 1 minus 8. So I just take it, plug it in for x. So I get 1 minus 2 minus 8 equals negative 9. Right? 1 minus 2 is negative 1. Negative 1 minus 8 is negative 9. And so now I've got enough information to graph this function. So all I have to do is set up the vertex form. So vertex form is h of x is going to be equal to a times x minus h squared plus k. And so h here, I just can't reiterate this enough. This h is not the same as this h. Right? I actually didn't mean to confuse you there. If I did, then I would just use f of x instead of h here. So everywhere you see an h with an x here in parentheses, just put an f there if that's too confusing. But I know a is 1 from my standard form quadratic. A is 1. And then I want to find this h value, which I just did a second ago. H is 1. Yeah. So I get minus 1 squared, and then my k value I just found, which is negative 9. And so this tells me that my function is shifting right 1 and then down 9. So right 1 and then down 9. So it should hit here, and I'm going to do this guy in indigo because it's my new favorite color. And something that I should note, as kind of like on the last video, right here, this is my axis of symmetry. Okay? So we've talked about that. Whenever you put this in vertex form, this right 1, this h value, if h is 1, that tells you where your vertex is. So h is 1, k is negative 9. So my vertex is 1, negative 9. But particularly my x value of my vertex is going to tell me where my axis of symmetry is. So that means any point on the same distance away from this axis of symmetry is going to be symmetrical. So if I go left 1 and up 1 here, then I'm going to also go right 1 and up 1 to put a point. So those points are symmetrical, okay? And the last thing that I can do is find these zeros. So I'm going to take this entire function and set it equal to 0. So I'm going to set this entire function, so let me do that in teal. This h of x, I'm going to set it equal to 0. This x minus 1 squared minus 9. So if I've got x minus 1 squared minus 9 equals 0, and I can add 9. So I've got x minus 1 squared equals 9, and I've got x minus 1 equals plus and minus 3. So if I take a square root there, just to show you, and then I can add 1 to both sides, and I get x equals 1 plus or minus 3. So this gives me two solutions. It gives me the 0, 1 minus 3, and then it gives me the solution 1 plus 3. So it tells me that this function over here is going to hit the x-axis of those two values, which is going to be negative 2 and positive 4. So I'm going to hit at negative 2. Right there, and at positive 4. And so what this allows me to do is graph my function. And that's what my function looks like. And so it becomes a little more helpful in order to see where this function is shifting. And you know the y-intercept of the graph by this point, hopefully. And then you also know how to find zeros whenever I have a function that's in vertex form, because that's one of the lessons we did. So we had problems like this where x minus 1 squared minus 9 is equal to 0. So this stuff kind of builds on each other, and so it doesn't go away. And so we're going to do maybe 2 more. So let me get another graph for you. So the next one we're going to do is x squared plus 16x minus 22. I'm going to go with the old f of x. Don't want to confuse you. And we've got a is 1. That coefficient on that x squared is 1. I've got b is 16. And I've got c is negative 22. So this time I'm going to have to change my scaling for my graph.
Lucas Beda, come to the office, please. Lucas Beda.
Ah. So I've got negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, negative 16, negative 18, negative 20, negative 22, negative 24. I'll just kind of keep going just in case, and I might have to extend that graph, but it's telling me that this function is going to hit at negative 22. That's the C term, right? So that's the y-axis. So whatever the C term is, that's where your function is going to hit the y-axis. So I'm going to pick a color. This time I think it's going to be green. Yeah, I'm going to make this function green. Yeah, let's make it green. Negative 22. Okay, so now I want to find my h value, which is negative b over 2a. And my b term is 16, so I've got negative 16 over 2 times 1. So negative 16 over 2 is negative 8. And so that gives me my h value. I've got my a value. So the only thing left to find is my k value. So k is going to equal f of negative 8. So you find h, then you plug it in. H is negative b over 2a. Negative b over 2a. So once you calculate that, you get negative 8 in this example. So you're going to plug that into the function to get your y value, which is your k. So I'm going to get negative 8 squared plus 16 times negative 8 minus 22. 64 plus 16 times negative 8. That's minus 128 should be. Just check that. Yep, and then minus 22. So I've got 64 minus 128 minus 22. So sometimes you have to change your scaling. So in this case, I have to change my scaling because my k value is negative 86. So, yeah, so it's negative 86. So a times x minus negative 8 squared. So it's shifting right. We'll talk about that. No, it's shifting left. That's correct. It's shifting left. Which a is 1. So that comes from up there. So a is 1. And then my k value is negative 86. So x plus 8 squared minus 86 equals f of x. So that's f of x. And so, right, I've got this shifts left 8. So left 8. So my vertex is negative 8, negative 86. So let's take a look at this. I'm actually going to change the scaling here. Go by 5s. So if I change that scaling, got negative 5, negative 10, negative 15, negative 20, negative 25, negative 30, negative 35, negative 40, negative 45, negative 50, negative 55, negative 60, negative 65, negative 70. Continue this guy down. Negative 75, negative 80, negative 85, and then negative 90. So that was a pretty big whopping function. So he's all the way down there. And then I'm going to shift left 8. So I'm going to take this scaling. So this is not completely to scale, but it's going to allow us to graph this function. So we'll see if that's enough. Probably isn't, but negative 8, negative 86. No, it's going to hit down here. So just below negative 8, negative 86. So right about there. And I know that the y-intercept is negative 22, so it's like way up here. And so, yeah, I'm going to have definitely a lot more terms, but let's just see if we can calculate this guy out. I've got x plus 8 squared minus 86 equals 0. So I'm going to add 86 to both sides. So I get x plus 8 squared equals 86. And then I can square root it. So I get x plus 8 equals plus or minus root 86. So I can't take the square root of that guy. So I get x is equal to negative 8 plus or minus root 86. So then I can use my calculator to calculate that. So let's go over to the calculator. So I've got two solutions here. I've got two x values. So x1 is going to equal negative 8 minus root 86. So that's one root. And then the other root is going to be negative 8 plus root 86. So that gives me 1.27 as my first 0, and then negative 8 minus square root of 86. Gives me my second 0. So negative 17 is my second 0, negative 17.27. So these are approximations. So my two solutions are exact. So we can talk about that. So the calculator loses precision whenever you type this stuff in. So negative 8 minus root 86. And then negative 8 plus root 86 is different than the numbers that we just calculated. Slightly different because of the extended properties of them, right? They have not all these decimals that this calculator is giving us, okay? So they've got all the decimals included. But rounding them allows us to see where it is on the graph. So I can go over here and I can kind of extend this graph, which I'm going to do. Negative 12, negative 14, negative 16, and then negative 18. It just so happened to fit. So I'm going to graph this function. It's going to hit 1.27, so right about here. And I know where my axis of symmetry is. My axis of symmetry is here. So I know that this function is going to curve up like this. And then I know also that if 0, negative 22 is a point, then if I move and I go to negative 16, I should have negative 22 is also a point. So, and then my other point would be negative 17.26. So right about here. And that is the graph of the function. So that was a little more dicey than the other few, but it is a quadratic and it is symmetrical. So I was kind of worried that we did that wrong, but that looks pretty accurate. So let's do one more, and we're almost finished. So. Yeah. So this one's going to be x squared x squared plus 8x plus 12. And so we want to find the opposite of b over 2a. So this is f of x. And I know where the y-intercept is already. So I'm going to go ahead and graph that function. I know that the y-intercept is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, a little higher. $11, $12. Just mark 13 for good measure. And so I graph this function, and it hits 12. Okay. And then I calculate h. It's going to be negative b over 2a. So opposite of b is negative 8 over 2 times 1. So 2 times 1 is 2. So negative 8 divided by 2, which is negative 4. So I've got a equals 1, b equals 8, and c equals 12. We've already used c to find the y-intercept, so now we need to find my k value by plugging negative 4 back in. So f of negative 4 is going to be negative 4 squared plus 8 times negative 4 plus 12. So that's going to be 16 minus 32. So minus 32, excuse me there. Plus 12. Well, negative 16 minus 32 is going to be negative 16. So negative 16 plus 12 gives me negative 4 again. So I've got a times x minus h squared plus k is also equal to f of x. So again, you're just changing the form to be able to shift that function. So this function, here's the claim, this function is the same as this one whenever I plug these values in. So a is 1. H is negative 4, so I've got negative of a negative is a positive, minus 4 on the outside. It's equal to f of x. So this gives me 1 x plus 4 squared minus 4 and so I set this entire function equal to 0. So I'm left with 1 times x plus 4 squared minus 4 equals 0. Okay? So what I can do is now I know, first of all, that where this function is shifting. It's shifting left 4. And over here it's shifting down 4. And I set it equal to 0 down here just to be able to find the zeros. So we'll do that here in a minute. But this is just to find the zeros here in a second. But this function is shifting left 4 and down 4. So left 4. So negative 1, negative 2, negative 3, negative 4. And since it's shifting left 4, I kind of want to extend this graph out because I'm not sure where it's going to hit the x-axis yet, but I've got a sense of where it's going to hit it. So negative 4 is my h value, so it's my vertex, the x-coordinate of my vertex, which is also called the axis of symmetry, so we talked about that. And then my k value is negative 4. So if I go left 4, down 4, 1, 2, 3, negative 4, that right there is my function. So I'll do this one in red. And so I've also got to find the zeros. So we're going to set this guy equal to 0 and solve it out. So I've got x plus 4 squared. And if I add 4 to both sides of this equation, then I get equals 4. And so I get, if I take the square root, x plus 4 equals plus minus 2. And then if I subtract 4 from both sides of the equation, I get negative 4 plus or minus 2. So my two solutions are negative 4 minus 2, which is negative 6, and then negative 4 plus 2, which is negative 2. So my two values is negative 6 and negative 2. And then, of course, I've got this symmetry. And so if you take a look here, from negative 4, 1, 2, 3, 4, 0 is 4 units away in this direction. And I go up to 12. So right up here, it tells me that if I go 4 right, I go up 12. So from negative 4, if I go 4 left from 0, from a y-axis of 0, so all the way to negative 8, I should also go up 12. So this is that symmetry. If you're not sure why that is, well, go back and look at lesson 8. But here it is. That's the axis of symmetry. So that tells me where that quadratic has that mirror image that we've talked about before. And so that's what it looks like. And that is it for this lesson. So that is a few different forms. Just make sure that you understand how to graph these, right? I would know where the y-intercept is by finding the c term. I'd know how to calculate negative b over 2a. I'd know how to find k value. I'd know how to shift the function. And I'd know symmetry. And I would definitely know how to do problems that have an a term that is not 1. So we're probably going to do some more practice with this. So this is a good starting point.